Solve. For example A, we have log of x base 2 is equal to 4. So when you're dealing with an equation like this that has just one logarithm on the left-hand side or right-hand side and then a constant on the other, all you have to do is to write into exponential form. So you're going to drop the log and switch the two positions that are here. So the 4 and the x will trade places, so you end up having 2 to the 4th is equal to x, and that's all you have to do. Evaluate 2 to the 4th after that, you will get the answer 16, and so x is equal to 16. All right, for example B, we have logs on both sides of the equation, so it's a little bit different. Instead of just having one log on the left-hand side of the equation, we have logs on both sides of the equations, but notice that the logs both have the same base, right? They both have a base of 7. That's important. Logarithms are one-to-one functions. So since we're taking the log on the left-hand side and we're taking the same kind of log of the right-hand side, the only way those two things could be equal is if what you're taking the log of here is equal to what you're taking the log of there. Does that make sense? So if you think about it, we're taking the log base 7 of 3x plus 6. For that to be equal to the log of 33 base 7, it must mean that 33 is equal to the 3x plus 6. So we're going to go ahead and write 3x plus 6 is equal to 33. And then we end up with the equation that 3x plus 6 is equal to 33. In other words, subtract 6 on both sides. You get that 3x is equal to 27. And then finally that x is equal to 9 when you divide both sides by 3. All right, and you can check the work here by saying, okay, what would happen if I plug 9 in? I would end up with log of 3 times 9 plus 6 base 7. And does that equal to log of 33 base 7? Well, 3 times 9, of course, is 27, and 27 plus 6 is 33. So, of course, it is true that log of 33 base 7 is equal to log of 33 base 7. So the answer checks. All right, let's finish up by doing C. So for example C, we have, again, logs on both sides of the equation, but we have these coefficients. So we have to move the coefficients up so they become exponents before we can drop the logs on both sides. So in other words, we're going to bring this 3 up here so that it becomes log of x to the 3rd base 5 is equal to, and we're going to bring this negative 1, remember a negative out in front is like a negative 1, we're going to bring that up here to make it log of 8 to the negative 1 power base 5. Then from there, since they're both logs with a base of 5 on both sides of the equation, we can go ahead and drop the logs and say that we have x cubed is equal to 8 to the negative 1 power. And that's the same as saying that x cubed is equal to 1 over 8 to the 1 power, because if you want to turn a negative exponent into a positive exponent, you just move it across the fraction bar, right? So we brought the 8 to the negative 1 to the denominator to make the exponent positive there. Now, from there, we need to take the cubed root of both sides, right? So we're going to do x is equal to the 3rd root of 1 over 8. And of course, the 3rd root of 1 is just 1, and the 3rd root of 8 is 2. In other words, you multiply 2 by itself 3 times to get 8. So your answer is 1/2.